What's more fun than the chain rule? Doing the chain rule twice. We can actually have as many function compositions as we want. If you wanted, right? Don't write this down. You could have f of g of h of I of j of k of x, and you could just use the chain rule a bunch of times. I'm not counting those parentheses. I think I guessed close. You take the derivative of the outside function, you'd leave all the insides the same, and then take the derivative of the inside function, but you'd have to use the chain rule again on the derivative of the inside function, so you'd multiply that by g prime of everything inside stayed the same, times the derivative of the inside, which is h prime, leave everything the same, blah, 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 okay? So it could get even really, it could get bad. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, I was close. Off by 1. So that's what we're doing here, but we're really only going to do it for 3. So if you want an official rule, here it is. But most people I know, again, don't really think about it this way, but it's an option. So now it's basically the chain rule, but twice. Gosh, there's too many parentheses. So if we have function composition with another function, so an inside function, an outside function, and a middle function, then k prime of x is just the derivative of the outside function, leave the inside alone, and multiply by the derivative of the inside function. Well, here, what's inside of h? It's f of g of x. So this, when I say use a chain rule twice, this is really what I mean. Because this red part right here is just the chain rule from the first video. So we're going to get that k prime of x equals h prime of f of g of x times f prime of g of x times g prime of x. If you'd like, you can use this formula. And there's, again, a very similar one with Leibniz notation. But the reality is that we usually just use the chain rule twice instead of using a more complicated formula. Let's do 2 examples. Example 5. Find the derivative of h of x. We should really use k to be consistent with our letters. K of x equals sine to the 6th of x cubed. And again, you could write this with f's and g's and h's, or could try to apply these and use the shortcut. Both are okay. You could also use Leibniz notation. A bunch of different ways that you can approach this problem. I would recommend starting again. This is an abbreviation. We have sine of x cubed to the 6th. It's usually a good idea to write it without that shorthand. That top version is just the shorthand, but this bottom version makes it easier to see what's actually, because this exponent is actually our outside function, whereas it looks like it's sine here. So the shorthand is a little misleading on these problems with trig. So now for k prime, we're going to take the derivative of the inside function, derivative of the outside function, that's the power rule. Leave the inside function alone, sine of x cubed. And multiply it by the derivative of the inside function. Now, the biggest recommendation I can give when you are doing this is when we're multiplying by the derivative of the inside function, I would write that down. If it's really messy, let's do it in an extra step. Don't try to do this in your head. All right, and then we can kind of simplify the first thing while working with the second thing. This first thing is just 6 times sine to the 5th. We can use the shorthand again now that we're done taking the derivative. And what's the derivative of the second part? Well, that's a chain rule. Derivative of the outside function is cosine. Leave the inside function alone and multiply by the derivative of this inside function. And now we can combine all our like terms. This becomes 18. We usually write the x's first. And we also usually write sines first. Sines before cosines usually. And as long as I collected all my terms correctly, this should be our answer for our derivative. Could check our answer by graphing some tangent lines, or just looking at the function and inspecting it that way as well. This is our answer. And again, we didn't even use this formula. You could call an F and an H and a G and use this formula. That would be fine. But I honestly think it's simpler to just do it this way. Last example of this video. We should name our particle. We should name it like Jeff or something. Jeff was the name of my loan officer. Jeff, pretty good guy. Anyway, not shilling for Jeff today. A particle named Jeff moves with position S of t equals the sine of 2t plus the cosine of 3t, where S in meters after t seconds. Yeah, all right, we're naming the particle Jeff. We'll see if I remember that for the next video. Calculus with Jeff and Jason. So the question is, what is Jeff's velocity? Jeff the particle. After pi over 6 seconds. Well, velocity is just the derivative. Oh, we don't even get to use the messy chain rule. We could make it more fun. Add like a cubed right there. Nah, we'll do another one in the next video anyway for more practice. So the velocity is just the derivative of position. Derivative of sine of 2t. Derivative of sine is cosine. Leave the inside the same. Multiply by the derivative of the inside. Now we have to take the derivative of cosine too. We can use the sum rule to say that really we just need the derivative of the first function and then add it to the derivative of the second function. This becomes minus sine of 3t times 3. And there really are so many layers to these problems. Like, we learn a concept, we do it out with the 30 million steps, and then a few days later, we just start taking shortcuts. And then we learn a new concept that also has 30 million steps. And then we learn like kind of how to do it a little faster. And that's one of the ways that calculus can be difficult is, right, I just use the sum rule without even a second thought, because I'm hoping at this point y'all are pretty comfortable with the sum rule. But really, if I wanted to do this, I'd write, okay, d dt of this plus d dt of this because of the sum rule, and then write out the steps for the chain rule, write out the comments about the derivative of trig. So it can be pretty difficult. If there's ever any point where you say, Jason, where did this come from? Or why can you use this? Just send me a question, send me an email or a Canvas message or something, and give me the timestamp. Say, hey, in video 3.6.3 at 7 minutes, 20 seconds, where did this step come from? All right. And that's a good way to ask questions. You can also show up to student hours with these questions as well. All right. So what have you got here? This is just 2 cosine of 2t minus 3 sine of 3t. And we are curious about the velocity after pi over 6 seconds. So we plug in pi over 6. Again, another warning, right? You can't just, we know this is true, but be very careful because this is not true. We can't plug in first. If you plug in first and take the derivative, you're always going to have 0. Because if you plug in first, you're getting a number, and once the derivative of a number, it's going to be 0. So please watch out for this. We have to find the whole function and plug in only at the very end. kind of a good rule of thumb for a lot of things in math, actually. Most things in math you can't plug in, or it's better if you don't plug in until the end, and some things you can't plug in until the end. So this is going to be cosine. What's double pi over 6? It's pi over 3. Double of 30 degrees is 60 degrees. Minus 3 times the sine of triple pi over 6. That's pi over 2. Triple 30 degrees is 90 degrees. And then again, we can use our reference triangle for the first one. Pi over 3 is 60 degrees. 30, 60, 90 triangle has these ratios. The second one, we can't use a triangle because the second one is 90 degrees. So for quadrantal angles, angles that end on one of the axes, angles that are these, 0, 90 degrees, 180, 360, you have to use the unit circle. Pi over 2 is right here, and sine refers to the y-coordinate. This is the point 0, 1. The y-coordinate is 1. Becomes 2 times the cosine of pi over 3. Pi over 3 is 60 degrees. Cosine is adjacent over hypotenuse. Cosine of pi over 3 is 1/2. Minus 3 times the sine. Sine is the y-coordinate, which is 1. That's going to be 1 minus 3, or negative 2. Negative 2 meters per second is our velocity. All right. This says that Jeff, our particle named Jeff, is moving to the left at a speed of 2 meters per second. So the negative says he's moving to the left, and our units are meters in seconds. So the rate, the velocity, is going to be meters per second. All right, and that's this video. Good luck. You should have everything you need to do the homework problems, but if you want to see some extra ones, then stay tuned. I've got the video for you.